All right. Good morning, everybody. So, have you seen my message earlier? I'm just asking if you want to continue today with the worksheet 6 and focus more on improper integrals or go over some review problems, probably from the practice test that Dr. Almus posted. But I understand that practice test also has an answer key uploaded in CASA. So I had some problems also prepared for practice for test number 2, or if you have specific questions, then kindly let me know. So just let me know your preference in the chat while I'm solving this problem that was sent by Arsalan earlier. So he said he needs some help with this particular problem. So I guess this is from the earlier part of the chapter. So the base of a solid is the region bounded by the y-axis, the lines x plus 5y equals 5 and x minus 5y equals 5. Find the volume of the solid if its cross sections that are if its cross sections are perpendicular. There should be no that are perpendicular to the x-axis are squares. Okay, so let's look at how the region looks like or how the base looks like. So I always want to start with a pictorial representation of the region so that it would be easier for me to analyze this problem. Oh, but it's also worth noting that the cross sections were said to be perpendicular to the x-axis. That tells us that we need to set up an integral involving the variable x. Okay. So for this kinds of solids, you're given the cross sections. You always integrate with respect to the variable to whose axis the cross sections are perpendicular to. Okay. Now let's see. So let's sketch the region. So first, oh, by the way, I will be integrating in x. So I want to express all the functions in terms of x. So for instance, the first function here, I'll write it as y equals 5 minus x all over 5, right? And then when x is equal to 0, y is 1. Let's put 1 here. And then when x is 5, y is 0. So this would be the 2 points for the first line. Oops, I missed a second point. Hold on. Okay. All right. And then the next one, let's use blue for that. So the second line would be y equals 5 minus x over negative 5, or that's the same as x minus 5 over 5. Okay. When x is 0, we get y equals negative 1. So we put something here. But when x is 5, y is also 0. We're lucky to get the point of intersection there. Okay. And then another boundary for this region is the y-axis, right? So the y-axis over here. So the region bounded by this 3 lines would be this rectangular region as we expected, all right? And then we were told that the cross sections for this particular problem are squares that are perpendicular to the x-axis. So a cross section will look like this. A square with the side lying on the x-axis or perpendicular to the x-axis pointing out of the screen. So imagine this square is pointing out of your screens. So those are the cross sections. And remember that the volume would be an integral with respect to the variable to whose axis the cross sections are perpendicular to. So I have a dx here. The bounds for x here would be x equals 0 and x equals 5. Because we notice that here the region starts when x is 0 and ends when x is equal to 5. So those are our bounds. And then the integrand would be the area of the cross sections, right? But the cross sections are squares, so we know that the area for the formula for the area of squares is s squared, right? So that will just be the side squared. But here we'll go back to the figure. and look at how long is the side. Well, if you want to measure the side, I'm going to look at this. How long is that? But that is exactly the vertical strip, right? And we measure the length of a vertical strip by doing top minus bottom. It's going to be the red line minus the blue line. And then, so that would be the side length. So side length equals top function, 5 minus x over 5, minus bottom function, which is the blue line, x minus 5 over 5 quantity squared. Then we simplify this integrand over here. So let's see, 5 minus, so I'll have a 1/5 over here. I'll just factor the common denominator 5. Or actually, this would be squared. So, and then what's left in the inside would be 5 minus negative 5. So that's going to be 10. And then it's going to be negative x minus x. So that's negative 2x. Okay, so this would be the integral that will give you the volume. Let me just rewrite it as in a better way. It's going to be 10 minus 2x quantity squared. Okay, then you just need to evaluate this integral. So I'll just rewrite it as 1 over 25. 100 minus 40x minus 4x squared dx, and I'll leave the rest to you guys. So yeah. Okay, is that okay, Arsalan?
Yeah, just a quick question. Can you explain how you went from the 5 minus x over 5 to the 1 over 5, 10 minus 2x? I got a little thrown off over there.
Okay, yeah, it's just a matter of simplifying. Note that here, I can factor a 1/5 because there is a 1/5 for both terms. So basically, I'll have 1/5 times what will be left. So for the first term, I have a 5 minus x left. And then after taking out the 1/5, on the second term, I'll have x minus 5 left, right? Then carry it out, carry the simplification out. So 1/5 goes here. And then 5 minus negative 5, that's going to be 10. And then negative x minus x, that's going to be negative 2x.
Okay, thank you. Got it.
Oh, yeah. Thank you, Joseph. Good catch. It should be a plus. All right. Okay. Thank you. I will always joke around that I did that in purpose to test if you guys are still listening. But yeah, thank you, Joseph. Good catch. So, okay. So now, have you decided, should we go over the rest of the examples from worksheet 6, or you want to do a quick recap of the topics from that is covered in the exam? You don't have any preference? Okay, yeah, that's fine. Though, yeah, I have some problems here that cover some of the things from the test. Yeah, this is I appended this to the practice test. But let's see. Let me know if you have some questions about the practice test, though we only have about 40 minutes left, so I'm not sure we can cover all the topics. But if you have some personal choice of topics, just let me know, because the others are very quiet, so I think they will just go with the flow. So don't be shy and send the specific topics. I have, how many problems here? Guess I have 6 problems over here. Though this doesn't cover everything, but I guess this would be some things probably I think would be the hardest, but I'm not sure which ones are hard for you. So yeah, let me know. So let's try. Yeah, I have some centroid problems, Muriel, so don't worry. We'll have that later. So okay, just remind me at 11:30 if I haven't gone through the centroid problems. Okay, let's look at these problems and then maybe browse through the easier ones. So question number 1, find the average value of 12x minus 6x squared on 0, 4. and determine a number C in this interval that equals the absolute value. So, oops. It's hard for me to remember the details in a problem, so I'll just copy paste it here. And I'll try to do this quickly because I guess this is easy. Remember, but just to recall the topics with you guys. So here we want to find the average value, and the average value has the formula 1 over the length of the interval. So that's b minus a, the right minus the left bound. In our particular problem, it's 4 and 0. And then we integrate from 0 to 4 the function 12x minus 6x squared dx. So this will basically give us the average value after evaluating the integral. Let's do this quickly. So I'll have 6x squared minus 2x cubed, right? Evaluated from 0 to 4. And then I'll plug in the upper bound and the lower bound. But luckily, when I plug in the lower bound 0, everything will just be 0. So it boils down to the upper bound. So this would be 4 squared 6 times 16 minus 2 times 4 cubed. I hate large numbers, but essentially this would be 1/4. Let's see if we can factor out some things. I can factor out the 16. So I'll have a 6 left here. And then I'll have, remember 4 cubed is the same as, oops, this is the same as 16 times 4, right? 4 squared times 4. So I factor out the 16. So what will be left would be 2 times 4. So there would be an 8 over here. I kindly double check my arithmetic here. Hopefully I didn't mess this up. And then so this would be 4. I can cancel there. So I'll have 4 times -2. So that's going to be -8. I usually hate working with large numbers, so as much as possible, I try to employ these tricks, factoring, cancellations, etc., rather than go and multiply 4 to itself 3 times, so it shouldn't be that hard. So that's the average value. The average value is -8. And then the follow-up question is to find a number C in the given interval 0 to 4 where f attains the average value. So you want to find C such that f of C equals f ave, right? The average value. But f of C is 12C minus 6C squared equals the average value of -8. So here we'll have, we'll have -6C squared plus 12C plus 8 equals 0. And then just to make the numbers smaller, I can divide both sides by 2. So I'll have a -3C squared plus 6C plus 4 equals 0. Then can we factor this easily? I'm not sure if this is factorable. So I'll try the quadratic formula. That's something that you can use for any particular quadratic equation. So I'll have -b, so that's going to be -36 plus or minus, it's -b, so it should be -6. It's already Friday. So, okay, -6 plus or minus root of b squared, so that's 36 minus 4 times -3 times 4 all over 2a, right? So this is using the quadratic formula. And then we simplify, so this would be -6 plus or minus root of 36. So I'll have 1648, so this would be plus 48 over -6. And then we'll have -6 plus or minus. I can factor out, well, let's just add this up. I'll have 84 over -6. Okay, then how can I factor 84? I can write 84 as what? 36. Well, I can write it as 42 times 2. But 42 can be further rewritten as 6 times 7, right? So, and then actually the best thing I can do here is to factor to take 4 out of the radical. So I'll have negative 6 plus or minus 2 root of 21 over negative 6. So this would be what? 1 minus plus root of 21 over 3. Okay. So, and then we are on the interval 0 to 4. Let me just do a quick calculator job here to see. I know that 1 minus root of 21 over 3 will not be in the given interval because that will be a negative number. Remember, we are just on the open interval, close interval 0 to 4. So I'll check 1 plus root of 21 over 3. If that gives us a number between 0 and 4. So yeah, and true enough, so the desired value for C is 1 plus root of 21 over 3. Because this is approximately 2.53. Okay? Is this okay, guys? Let me just double check my arithmetic here. Just making sure we have the right solution. But do you agree with the solution? I hate to commit a mistake here because I have to edit the video again. But okay, I think I got the right answer. Okay, thank you. Let's any question with that? I guess this is one of the first few topics that we considered here, the average value and the mean value theorem for integrals. So yeah, let's try problem 2. Oh, problem 2 is the centroid problem. So Muriel, here you go. Oops, just copy this. I guess we didn't evaluate the centroid. Okay, so you're Muriel, you're having troubles with a Y centroid. Do you mean in the setup or just in the evaluation? Okay, just let me know in the chat. Oh, the evaluation. Okay, let's see. Okay, let's sketch the region bounded by the curves y equals x squared plus 4, y equals 4, and x equals 2. So the first is the parabola. Yeah, sure, because usually I don't expect you to be given very complicated integrals for centroid, especially if you need to evaluate it, because that would be an overkill for an exam or a quiz. So yeah, perhaps double check your setup if you think the integral is very complicated or is more complicated than usual. So let's see, the curve would be y equals x squared plus 4. That's a parabola that opens, so this one. It's a parabola that opens upward with vertex at x equals 0. If x is 0, y is 4. And then when x is equal to 1, then I get a 5. Also if x is negative 1. So and then y equals 4. So y equals 4 over here. And oops, I should have used a different color here. This is y equals 4. This is y equals x squared plus 4. And then x equals 2. So let's put x equals 2 here. Okay, so the shaded region would be, or the bounded region will be this. And we need to find the centroid, okay? Now, in computing the centroid, we need to compute the area first because the area goes into the denominator of the centroid. So you can either do this in terms of x or in terms of y. But I guess it would be easier to take advantage of the fact that the functions are given in terms of x. So let's use vertical strips. Okay. So this would be an integral in x. The bounds would be from 0 to 2 because the region started at 0 and ended up at x equals 2. And then this is just the area, so it would be the length of the strip inside the integral. So it's going to be top minus bottom, so it's going to be x squared plus 4 minus 4. And good thing, this would be just 0 to 2 of x squared dx. And then this would be x cubed all over 3, evaluated from 0 to 2. So it's going to be 8 thirds. Okay. All right, so that's going to be the area. Now for the centroid, okay, so the centroid would be at x bar, y bar, where the x coordinate, x bar, is given by an integral over the area. So we'll have the area 8 thirds in the denominator. And then here, we'll just take the average of the x's weighted by f of x minus g of x. So basically, we'll have x squared plus 4 minus 4 dx from 0 to 2. And then since we are averaging the x's, so there should be an x inside the integral, right? So the thing here is you copy the variable, if possible, or if permitted, inside the integral. And then the weight here would be the integral that you used in the finding the area. Okay, so it's going to be f of x minus g of x. So I have the identical thing as in the integrand in the area. So that's one thing you can remember. So whatever the integrand in the area, that goes into the numerator of the x coordinate and the y coordinate as well of the centroid, multiplied by the variable that you want to average. So here I'm looking for x bar, so I want to average the x's, but they will be weighted by the integrand that appeared in the area, which is f of x minus g of x, right? So simplifying, I'll get the 8 thirds in the denominator can be written as 8 thirds. Integral from 0 to 2. We knew that this guy, this weighting factor here, will be reduced to x squared. So we'll have an x cubed dx over here. Then integrate, so we'll have 3/8 times x to the 4th all over 4, evaluated from 0 to 2. So this would be 3/8 times 2 to the 4th all over 4. But I knew that 2 to the 4th, I can cancel the 4 here, so there would be a 4 left here. 4 will be canceled by the 8 here. It will be 2 left, so 3/2. Okay, so that means the centroid, or the x coordinate of the centroid, will occur at 3/2, which makes sense because 3/2 is between 0 and 2. So if you got a number that is outside the interval 0 to 2, then something must be wrong, because the centroid is the geometric center of the shaded region, so it should be inside the shaded region. So here, let's say 3/2 is over here. So I guess we are on the right track for the x bar. Then for the y bar, there's still the area in the denominator. And then we still integrate against the integrand that appeared in the area. So that's f of x minus g of x. But here, we are averaging the y value. So supposedly, we'll put a y here. But unfortunately, this is not valid because we are integrating with respect to x. So that means I cannot put the y inside the integral. But instead, I'll just recall that here we're looking for the average y values, right? So to get the average y values, let's go back to the region again. So for each of the strips here, I'm looking for the middle y value. The middle y value for each of the strips will just be the average between the top function and the lower function. So remember, how do we get the average? So it would be the top function plus lower function all over 2, right? That's the average between the red and the purple line, graphs, right? So you're looking at the middle. So to get the middle of that strip, you take the average. So, and then to get the average, the formula is just take the sum. So we'll have x squared plus 4 all over 2. And then we simplify. So this will just be, oops, let me use red again, black again. So this would be 3/8 integral from 0 to 2, or actually, okay, let me just continue this. So this would be x squared plus 4 quantity squared minus 16 all over, or actually it would be easier to just do it this way. I'll have x squared plus 8 all over 2 times x squared dx. So this would be 3 over 16. I factored out the 1/2, 0 to 2 of x to the 4th plus 8x squared dx. Okay. And then let's carry on with the integration. So we'll have x to the 5th all over 5 plus...
shouldn't it be x to 2 plus 4 minus 4? Because it's the top minus the bottom.
Which one? For the pink expression here?
Yeah, shouldn't it be minus 4 instead of plus 4?
Well, here, remember this is the average y value, okay? And for the average y value, we get f plus g all over 2.
Oh, okay.
So perhaps that's what went wrong in your setup, because here I cannot plug in the y because I'm integrating with respect to x. So instead, since I cannot put y, I write the average value for y. And the average values for y would be the top function plus the bottom function, and then divide the sum by 2. That's the average, right? Or perhaps if you memorize the formula from the lecture, I guess they presented it as over the area, integral of 1/2 times f of x squared minus g of x squared. This is another way of looking at it. So it's the upper function squared minus the lower function squared times a 1/2. But I just wanted to present it this way, just to emphasize that the formula was based on finding the middle y value for every vertical strip. Okay. Is that clear now?
Yeah, that's a bit clear. So just to make it easier for the test, you suggest to memorize the formula?
Well, if you're good at memorizing formula, then go ahead. But if you're like me who hates formula, I always go back to the definition. It's easier for me to remember things in the context of the discussion. So the formulas, I usually prefer to write it in terms of the geometric setup or the setup that makes sense to me. But by all means, if you're good at memorizing, then use this alternative formula, which will give you the same answer, by the way.
Okay, thank you.
Right. Okay, then let's continue. I hope somebody's checking my arithmetic here. So it's going to be 8x cubed all over 3, evaluated from 0 to 2. And here we go again. We need to simplify. So this would be 3 over 16 times 2 to the 5th is 32 over 5. Oh, it's not that bad. Plus 2 cubed is 8, so that's 64 over 3. Okay, and then I can factor out the 16 from the inside terms. So if I do so, I'll have 2/5 plus 4/3, and then the 16s will cancel. So I'll have a 3 here, and then I'll have a 6 plus 20 over 15. So that's gonna be I can cancel the 3's here. So I'll have 5 here, 26 over 5. And 26 over 5 is what? 5.2. And that should be fine because the region, it should be somewhere here. Oh, 5.2. Okay, somewhere over there. Of course, my region was drawn not to scale, so yeah. But that should be the geometric center. Okay. I think I'm going too fast, but do you have questions, guys? Are you still with me? I don't know what's happening here in my office. It's very hot in here. But any questions so far, guys? I see that there's just actually how many? 10, about 14 of us or 15. I don't know what happened to the others. Are they taking the exam or what? Okay, let's try problem 3 then. And again, don't be shy. You can send your own questions. These are just some guide questions while I'm waiting for you guys to send in your questions. So if you have a specific topic that you think you need help, just let me know. Or even if you have specific questions, just send them in the chat. So while waiting for that, let's look at problem 3. So here we want to set up the integral that will find the area of the surface obtained by revolving f of x equals 4 cosine x with x going from 0 to pi over 3 about the x-axis. Okay, let's try to work this out. I always begin with the region. X equals 0 to pi over 3, so that should be over here. And then when x is 0, cosine of 0 is 1 times 4, so we'll start at 4. And then what's another special number between 0 and pi over 3? I guess the only one is pi over 6, but cosine of pi over 6 is root 3 over 2. So I guess it's easier to find the cosine of pi over 3. If I'm not mistaken, cosine of pi over 3 is 1/2. So 4 times 1/2, so that's going to be 2. Is that correct, guys? Cosine of pi over 3 is 1/2. Because honestly, I cannot compute those angles without drawing a unit circle on the side. Okay, I guess you're better at me calculating those. Okay, good. So now, so this is our arc, and we want to revolve it around the x-axis, and we want to find what's the surface area of this the surface area of this solid or this surface. Okay, now remember that for the surface area, so the formula would be 2 pi RH, 2 pi RL, right, from A to B with respect to some variable. So let's just say dx. R is the radius of a strip. I don't know how to call it, but this would be the radius of the strip, but you can measure it by looking at the distance between a point on the curve and the AOR, and L is just the arc length, or the integral for the arc length, right? But remember that the formula for the arc length requires us to have the square of the derivative. So let's go here. So if f of x is 4 cosine x, then f of x, or f prime of x, the derivative would be -4 sine x. And then remember, I need to square this. So f prime of x quantity squared is just 16 sine squared x. So let's keep that aside. Okay, now to have the final integral, so a and b are the starting and the ending x values for the arc. So this is our arc. It started at x equals 0 and ended up at x equals pi over 3. So they would be the bounds, 2 pi. And then r is the radius or the distance between a point on the curve and the AOR. So we measure it this way. Take a point on the curve, measure the distance from the AOR. The AOR is the x-axis. So here, it's a vertical strip. So we do top minus bottom. So it would be 4 cosine x minus 0. So we'll just put 4 cosine x here as our r value. And then the arc length, or the contribution from the arc length, would be the square root of 1 plus the derivative squared. But we knew that the derivative squared was 16 sine squared x dx. And luckily here, we were just asked to set up the integral. So I'll stop there, right? So that's also one thing, helpful thing that you can do in the exam. Take note of the instruction. Some problems will ask you to find the volume or find the area, find the surface area. If that's the case, you need to evaluate the integral. But if you are just asked to set up or give the integral, then do not simplify, because you won't get any extra credit if you evaluate the integral correctly. So you'll just be wasting time. So yeah, just take note if you're just asked to set up or to find the volume or the area. Okay. Questions for this one? I see Herson's question. Can you remind me what is 7.4 and 7.5? I already forgot. Are they volumes? Let me see if I can pull that up before Herson replies. Okay. Yeah, good. Volume, arc length, and surface area. So I guess we have the previous example is about surface areas. I hope that helps. Let me know if you have a follow-up question there. But let's look at volume problems. Let's see. I look at the practice test and perhaps we can get some problems here. Yeah, I encircled problem 7. So let's try this. Oh, what happened? Hold on. Yeah, I know that this example involves pretty basic functions. So will that be okay? Because I guess the crucial thing here is for you to understand the process rather than working with very complicated functions and be concerned with a lot of details. But here I want you to focus on the concepts, because that's all that matters. If you know the concept, whatever complicated function is thrown at you, then with little patience and diligence, you can find the right answer. So I usually focus more on the process rather than this very complicated or show-off functions. Okay, and I guess this is a good exercise because here we are given several cases. I mean, you're required to use the dishwasher shell method with different axes of revolution. My only misgiving here is that all problems only has the coordinate axis as the axis of revolution. So perhaps we can mix things up with some examples later. But in any case, let's start with sketching the graph, because this is crucial. I guess this is the most crucial part when solving volume or area problems. Have a good idea of how the region looks like. So x equals y squared. Well, that's just a parabola that opens to the right because the squared variable is y. So if y is 0, x will also be 0. So I'll have a point here. When y is equal to plus or minus 1, x would be equal to 1. So that means this is the graph of x equals y squared. And then the other one is x equals y equals x over 4. So when x is 0, y is 0. Lucky us, 1 point of intersection down. And then when x is equal to say 4, y is equal to 1. And then that would be the line. Y equals x over 4. That means I need to extend my parabola a little bit. And we need to solve for that point of intersection there, right? Let me just fix this up. Okay, and so the shaded region is over here. And then let me copy this for later. Okay. Now let's look at the points of intersection first. We know that they will intersect at the origin, but what would be the other point of intersection here? So in order for us to find that, well, I'll have to write this as x equals 4y, because the other equation is given in terms of y. So I'll just need to equate those two functions together. So here in the first function, or in the line, you see that x equals 4y. In the parabola, x equals y squared. So these are two expressions for x, so we can put them equal to each other. So I'll have y squared equals 4y. And so here I can write it as y squared minus 4y equals 0. Factor out y. And here we see that y equals 0 or y equals 4. So it turns out that this happens at y equals 4. But what is the x value when y is 4? When y equals 4, you can either go to this equation or this equation to find a value of x. I'll go to the, or actually, either of them will give you x equals 16. Right, so this is x equals 16. So maybe I should copy this one. Now we have the points of intersection. Okay. Now let's answer part A. So for part A, we want to have the integral that gives the volume if the region is rotated about the x-axis. Axis of revolution is the x-axis, and we were asked to use the disk or the washer method. For the disk and the washer method to be applicable, the strips that you are using should be perpendicular to the axis of revolution. In this particular case, the axis of revolution is horizontal. So for the disk or the washer method to apply, we need vertical strips. Right? That's always the case. Disk washer requires perpendicular strips. So here the strip should be perpendicular to the AOR, so it should be vertical. And vertical strips always require the variable x. Vertical strips x, horizontal strips y. Okay. Now we know that we need to integrate with respect to x. The bounds would be according to x. Region started here at x equals 0 and ended up at x equals 16. So the bounds would be from 0 to 16. And then here, disk or washer, we will use the washer method because the vertical strips from the AOR towards the end of the region will involve some parts that are outside the shaded region. So basically, I need to use the washer method here. Again, if you draw a strip from the AOR towards the last portion of the region or to the edge of the region, if you see part of that strip goes outside the shaded region, then it's a washer method. Otherwise, it's the disk method, right? It's important to identify if it's a disk or a washer because they have the different formulas, right? So for the washer method, the formula is pi times outer radius squared minus inner radius squared. The idea behind that is that if you do the revolution, you see that, I hope you can imagine that when you do the revolution here, the inside of the solid will be hollow, or some part of the inside would be hollow, right? So the thing here in the washer method, we're computing the area as if there is no hollow. Hence, you have the outer radius squared. But we need to subtract from that the volume of the hollow, which is represented by the inner radius. So that's why you have the difference of two squares over there. Now, outer radius squared. The outer radius squared is this long strip over here. You just imagine there is no hollow for a moment. So you imagine this to be a complete solid in the interior. So we need the outer radius squared. So that's going to be top minus bottom. The top is x equals y squared. Oops, but there. I cannot work with x equals y squared because I need to integrate with respect to x. So I solve for y in terms of x. So that's going to be y equals plus or minus root x. And since we are using the upper half of the parabola will use the positive root of x, right? So that's the top function. So this is positive root of x. The bottom function, actually, but we don't need that. But just for completion, this is y equals negative root x. And so it's top minus bottom. So that's going to be root x minus 0. So we'll have a root x in our first term here, minus the inner radius, or the smaller radius. The smaller radius is the radius corresponding to the hollow, right? Because we need to subtract from the volume of the complete solid, the volume of the hollow, right? So the volume of the hollow will correspond to a radius consisting of this length, right? Top minus bottom here, the top function is the blue line, which is x over 4 minus 0 again. So there would be an x over 4 here. And that's going to be the volume using the disk or the washer method. Okay. All right. So I hope that's clear before we proceed to part B. For part B, I think we still have the same region, same axis of revolution, but this time we need to use the shell method. Okay. So this is the AOR still. For the shell method to be applicable, the strip should be parallel to the axis of revolution. In this case, the axis of revolution is still horizontal. So to get parallel strips, we need to use horizontal strips. And remember, horizontal strips go with a variable y. All right. And then since we are integrating with respect to y, the bounds will correspond to bounds for y. The region started here when y equals 0 and ends here when y is equal to 4. So the bounds should be from 0 until 4. And then remember, we're talking about the shells method here. For that, the integrand should be 2 pi radius times height. And then I'll just copy the constant 2 pi over there. The radius, well, it would be easier to visualize this if you can draw the cylinders. So if you do the revolution, you'll have cylinders that look like this. At least half of the cylinders look like this, right? And then the radius would be this length over here. Okay. And remember the convention, whenever measuring something from the x-axis upward, that's always y units, okay? And can we put y inside the integral? Luckily, yes, because we are integrating with respect to y. So the radius is y times the height. Well, the height of the cylinder is this. But that is basically a horizontal strip, okay? And we measure the length of a horizontal strip by doing right minus left. So here we'll have right minus left, but here we need to have the variable y. So from this, I get x equals 4y. So that means here I'll have right, which is 4y, minus left, which is the blue curve, y squared. And that will be the integral that will give you the volume using cylindrical shells. Okay. And I guess the process is the same for C and D, except that you will be using the y as the axis of revolution. So the type of strips will also be flipped, because now instead of a horizontal AOR, you'll have a vertical AOR. So I don't think we have time to go over that, but let me just take another minute to show you what happens if, say, I want the axis of revolution to be, say, over here. Let's say y equals -2, okay? And then say I want to use horizontal strips. So if that's the case, then the volume, so this is my AOR now, okay? If I want to use horizontal strips, Then I need to integrate with respect to y. And then the bounds would be bounds for y. So still, regardless of where the axis of revolution lies, it's still 0 to 4 because we look at the shaded region, right? Shaded region starts at y equals 0 and ends at y equals 4. And then since the strip that I chose is horizontal, the same as the axis of revolution, so I use cylindrical shells. So I'll have a 2 pi here, and then the radius. Well, how does the cylinder, or how does a cylinder look like here? Well, a cylinder will be like this, or half of a cylinder will look like this. Okay, so and then the radius will be the distance from here until the AOR. So that would be our radius, right? But notice that from here until here, from the AOR towards the x-axis, that's always 2 units, okay? But remember, starting from the x-axis upward, that's always y units. So the total length of the radius would be y plus 2. I don't know if you will be given complicated, or I mean, AORs that are not the coordinate axis, but it is not that difficult as long as you can imagine how the cylinders look like, right? And then the height of the cylinder will still be this, which is the length of the horizontal strip. So still right minus left. So here we'll have the right function is 4y minus the left function is y squared. I use the same thing here. Okay, good. And that's it. That will be the integral that will give you the area. Sorry, the volume of this solid. Okay. Oh, that went too fast. Yeah, the hour went too fast. But do you have some further questions or some quick questions? Because unfortunately, I still have a class after this, another Cal 2 lab, so I can't stay too long. But do you have quick questions?
Yeah, so why is it y plus 2 and not 4y plus 2?
4y plus 2. Well, it is because the upper the radius will not it doesn't lie at 4y always, right? Because here you can have the radius measured from here. This is also a radius. And that will not lie on the blue line. So we don't have any basis to say that that would be 4y because it doesn't lie at any part of the graph at all. And actually 4y is an x value. So yeah.
Okay, that makes a lot of sense. Thank you.
Right. So you just remember the convention that whenever measuring something from the x-axis upward arbitrarily, that's y units. And if you're measuring something from the x-axis, y-axis towards the right, that's always x units. So yeah, that would be helpful for the cylindrical shells method. All right.
Okay, thank you very much.
Okay, you're welcome. So good luck, guys, on your test. Then let's see each other again on Monday, and let me know how the exam went. All right, have a good weekend, everybody.